Hello dear students, as you know we are doing chapter number 12, class 12, chapter number 9, it is ray optics, and we have done 3 parts of it. Today we are going to do the 4th part, and by today I'll try to finish the reflection part. From tomorrow, means from the next video lecture, I'll start the refraction. Okay, so let us start what we have done last time. We have proved the mirror formula, which is 1 upon f is equal to 1 upon v plus 1 upon u. Okay, by using simple geometrical concepts we have proved this formula, and this formula is called what? It is called mirror formula. Now the question is, one more topic is there related to it, and that thing is magnification. Now what is magnification? Okay, what is magnification? So magnification is a comparative view. It is an approach through which we can see whether the image produced by the mirror is greater than or is smaller than the object. So magnification, basically it is denoted by small m, and it denoted by height of the image produced upon height of the object. And moreover, it is also given as minus times v upon u. What is v? V is the image distance. What is u? U is the object distance. Okay. You need to understand one thing, from where that minus v upon u has come. For any kind of mirror, for any of its position, if the object and images are not at infinities, one ray is always there which pass on pole, and then it gets reflected back. Somewhere here its image is formed, suppose. Okay, obviously two rays are there, so one ray, let the one ray will be like this. One ray passes like this, so image is formed somewhere here. This is your focus, this is your 2f, object is beyond 2f, object is beyond center of curvature, right? So this is the ray diagram. Okay, so in this one we always have two triangles in such a manner that they are similar to each other. Just see, we have ABP, triangle ABP, and the triangle A dash B dash P. They are similar to each other. One angle is 90 degree, another angle. These two angles are going to be equal only, because one is angle of incidence, other is angle of reflection. So basically these two triangles are similar to each other, and if they are similar to each other, what we can write? We can write the ratio of corresponding sides are equal. So ratio of corresponding sides means perpendicular. Here the perpendicular is AB upon base, it is PA, which is equal to perpendicular A dash B dash, which is upon PA dash. So basically what we have got here, from here, if this A dash AB is transferred to this side, PA transferred to this side, we get A dash B dash upon AB, which is equal to PA dash upon PA. Now A dash B dash is the height of the image, which is inverted, height of the object. PA dash is the image distance minus V, PA is object distance minus U. Why all these are minus? Height of the image is negative because the image is formed inverted. Minus V I have put because PA dash is going this side, ray of light is this side, incident light. So basically this is also negative, and U is negative for the same reason. So one minus sign will be cancelled out, but again one minus sign is there. So what we can write? We can write H dash upon H is equal to what? Minus times V upon U. And H dash upon H is defined as magnification, so it can be written as minus V upon U. Okay, so it is a kind of proof which is not required. Just for your curiosity ki from where this term has come, I have given a geometrical explanation. So magnification is given by H dash upon H, which is equal to minus V upon U. Sometimes that magnification is required in terms of focal length and the image distance. in terms of focal length and the image distance. In those cases, what we are required to do, just see. Also, 1 upon f is equal to 1 upon v plus 1 upon u. It is the mirror formula. Just multiplied by v. We'll have v upon f is equal to 1 plus v upon u. Or we can write v upon f minus 1 is equal to v upon u can be written as minus m. So it will be like minus m. Or m will be equal to 1 minus v upon f. Or m will be f minus v upon f. So this is the formula for magnification in terms of focal length and the image distance. Moreover, sometimes magnification is required in terms of focal length and object distance. For that thing, let us multiply that mirror formula, which is 1 upon f is equal to 1 upon v plus 1 upon u this time. So it will be u upon f is equal to u upon v plus 1. Plus 1 is transferred to this side. It will be like u upon f minus 1 is equal to u upon v. If it would have been v upon u, we can write minus m. But right now it is u upon v. We should write minus 1 upon m. Now this minus is transferred to this side. It will become 1 by m is equal to 1 minus u by f, or 1 by m is equal to f minus u upon f, or m is equal to f upon f minus u. So this is the magnification in terms of focal length and object distance. Okay, all these three formulas are used to calculate the magnification. Magnification gives us the value of a comparative ratio of height of the image to the height of the object. Now there are some features related with magnification. If magnitude of magnification is greater than 1, it simply indicates that image is magnified. Image is magnified. Why is it so? If magnitude of m is greater than 1, so magnitude of m is greater than 1, it simply means h dash upon h is greater than 1, which simply indicates that h dash is greater than h. So height of the image is greater than height of the object, and that is why the image is magnified. Moreover, second, if magnitude of magnification is less than 1, which implies that h dash upon h is less than 1, which implies that h dash is less than h. So basically height of the image is less than height of the object. So here that image is diminished. Image is diminished. What is diminished? Diminished is what? The size of the image is less than the size of the object. And if m is equal to 1, then it simply means that h dash is equal to h. And what does it mean? The image is of same size. Image is of same size. So these three possibilities are there. Also, there are more possibilities, like if m is positive, it simply indicates that image is erected. Image is erected and virtual. Why I'm saying virtual? In case of concave mirror or convex mirror, when the image is formed behind the mirror, then only it is erected and virtual. That is why if m is positive, it simply means that the height of the image is positive. And if height of the image is positive, it simply means that image is erected. And if it is erected, it had to be virtual also. If m is negative, then the image is real and inverted. So need to understand these points. If magnitude of magnification is greater than 1, image is magnified. If magnitude of magnification is less than 1, image is diminished. If magnitude of magnification is 1, image is of same size that of object. If magnification is positive, image is erected and virtual. If magnification is negative, image is real and inverted. So all these points are related to magnification produced by a concave or convex mirror. Okay, so this was all about. You should note down it. Okay, pause the screen and note down. Now this concave mirror we are done with. We are done with concave mirror and convex mirror. Now what we should learn? We should learn the use of concave mirror and convex mirror. What are the uses? I hope you must have studied in class 10th also. The use of concave mirror and convex mirror in our day-to-day life. Concave mirrors are used where a magnified image has to be seen of certain object, then concave mirror is used. Property of concave mirror, that when an object is placed between focal length between f and p, its magnified image is formed. So that very property makes it very useful. Okay, I have discussed it before also in lecture 2 or 3 probably. Okay, that when an object is placed between p and f, the image formed is virtual and it is erected. So that this properties makes that concave mirror very useful. Dentists use concave mirror to see the magnified view of the cavity formed in the cavity. Okay, makeup mirror, shaving kit mirror, they are concave mirror slightly because when they are put close to the face, okay, so we can see the magnified image of this face, and so that we can work on it. Concave mirrors are also used in headlights of the car, headlights of the street lights. It is used. That is not concave, that is parabolic. But again, if this is a bulb, so bulb is sending its light everywhere, light is going upward also. So from the concave mirror it gets reflected back to the downward only. So this is how this concave mirror is used in headlights of the car or in street lights. Is it clear? Concave mirrors are also used in dentist clinic, as I have told you. It is used in shaving mirror and makeup kit mirror. So, okay, where are the convex mirrors are used? Convex mirrors are used in rear view mirrors in the cars or the bikes. Okay, this is also has been discussed in the last class, that convex mirror has a large field of view. Suppose if a plane mirror is being applied in rear view mirror, so for a particular object, what is the field of view? Say this is your observer, so how much he can see? So he can see this much. Okay, this much field of view it covers a plane mirror. But for the same distance, if a convex mirror is placed, then the field of view something is like this. Field of view is larger. Is it clear? So that is why this convex mirror is being used. This makes the convex mirror very useful. Okay, wherever a sight is rare or sight is not visible, okay, at sharp turns, if you have been to malls or multi-level parkings, you must have seen at the sharp turns convex mirrors are placed. Okay, so that if a bike or car is going this way, and suppose the way of this multi-level parking is like this. Okay, so if you are going this way, a convex mirror is placed here, so that in that mirror you can see the vehicles coming from this side. Okay, so these are the some uses of convex mirrors. So these are some uses of concave mirror and convex mirror. Okay, now what we are going to do, we are going to solve a very important NCERT numerical, and then after we'll move to refractions. The question number is 9.15. Okay, 9.15. 4 parts are there. Let us discuss them one by one. A part. Use the mirror equation to deduce that an object is placed between f and 2f. F and 2f. 2f means center of curvature C. Of a concave mirror produces a real image beyond 2f. If the object is placed here, the image should be beyond 2f or beyond C. That we have to prove. Okay, we are not going to make ray diagrams to prove, because in the question it is given that use the mirror equation to deduce that. Okay, so basically here we need to find image distance. So from mirror equation 1 upon f is equal to 1 upon v plus 1 upon u. From here, if 1 upon v need to be calculated, so it will be 1 upon v is equal to 1 upon f minus 1 upon u. So 1 upon f minus 1 upon u is what? It is basically the image 1 upon v. V is what? Image distance, right? Okay, very good. Now if we apply the sign convention over here, or let it be like this. Okay, let it be like that. But remember, when the object is placed between f and 2f, its u has to be what? Negative. Its u has to be negative, and focal length is also what? Negative. Okay, we cannot say about v, because for v we need to prove. Okay, let us prove that. So as per the question, the value of u, magnitude of u must be between f and 2f. So it should be greater than f. It should be greater than f, and it should be less than 2f. It should be less than 2f. Now just see, f, u and 2f, all these three numbers are negative. So when we just remove this magnitude sign, the inequality will be changed. Let me give you a hint from that. Like suppose minus 3 is greater than minus 1, which is true. Minus 3, magnitude of minus 3 is 3, magnitude of minus 1 is 1. So minus 3 ka magnitude is greater than minus 1 ka magnitude. Now just see, if I remove this magnitude, and now I want to write the inequality. How the inequality will be? Now which is greater, minus 3 or minus 1? Obviously minus 1 is greater. Same thing will happen over here. 2f is negative, u is negative, f is negative, u is negative, 2f is negative. So when I want to remove that magnitude sign, what I'll have? I have to write f is greater than u is greater than 2f. Is it clear? Now what I'm going to do? I'm going to reciprocal it. So again that inequality will change. 1 upon f is less than 1 upon u is less than 1 upon 2f. Now just remember this thing. We need to bring this thing in the mid. For that, what we do? We have to put a negative sign, and because of that, again that inequality changes. So it will be like minus 1 by f is greater than minus 1 by u is greater than minus 1 by 2f. Now 1 by f is added all the three terms. What we are going to have now? Minus 1 upon f plus 1 upon f minus 1 by u plus 1 upon f minus 1 by 2f plus 1 by f. Now it will be 0. So it will be 0. Here it can be written as 1 upon f minus 1 upon u. And here the LCM will be 2f. So it will be like minus 1 plus 2. 2 minus 1, it is 1. And that too with plus sign. So it can be written as now 0 is greater than 1 upon f minus 1 upon u is 1 upon v. So 1 upon v is greater than 1 upon 2f. Now if I reciprocal it again, I have to change the inequality. So it will be like the reciprocal of 0 is infinity, is less than 1 upon v is less than 2f. So v should be less than 2f and it should be less than infinity. Okay, v should be, remember that f was negative, so it should be negative infinity, right? So basically v should be less than 2f. V should be less than 2f. And if v should be less than 2f, remember that 2f is negative. So if 2f is negative and v is again is less than, like suppose I am writing a variable for x which is less than minus 10. So what can be the values of x? The values of x can be -11, -12, -13, -14, -15, like that. So if I want to write magnitude, so magnitude of x is greater than magnitude of 2f, magnitude of -10. Will it be like this? Because the values of x was, probable values of x was -1, -11, -12, -13, whose magnitudes are greater than -10. Same happens here. If v is less than 2f, we can write magnitude of v is greater than magnitude of 2f. So v is formed, the image is formed always beyond 2f. The image is formed always beyond 2f because v is greater than 2f. That we need to prove. Okay, so this is what we have been asked in the question. Okay, this is what we have been asked in this question. So v should be, the magnitude of v is always greater than 2f. Question was real image. Also we need to prove that image is real. So for that thing, if it is produced in front of a concave mirror, the image has to be real also. The image has to be real also. Okay, so v is greater than 2f, it has been proved. So this is the part 1 of the question. Okay, pause the screen and note down. These informations were given and that has to be proved. Okay, let us move to the next one. Next question is part B, 9.1 part B. Let me remove all this. I hope you are clear with the inequality. If inequality you don't know, you will not be able to understand these questions. Okay. Now let us move to the next part. The next part of the question is, a convex mirror produces B. Again, use the mirror equation to prove the thing. A convex mirror produces a virtual image independent of the location of the object. Means we need to prove that a convex mirror always produces virtual image. ठीक है, virtual image. That we need to prove. Okay, let us try to do it. Again, let us start with mirror formula. For mirror formula, 1 upon f is equal to 1 upon v plus 1 upon u. From here, that 1 upon v has to be 1 upon f minus 1 upon u. Now for a convex mirror, what are the variables? How the variables are? F is positive and u is negative. F is positive and u is negative. Okay, very good. Now just see, in convex mirror, if f is positive and u is negative, just simply see this thing. 1 upon v is equal to 1 upon f minus 1 upon u. Now from the formula, what you was looking at, 1 upon f is something positive, minus 1 upon u is also positive, u is negative, so minus 1 by u is what? It is positive. Okay, minus 1 by u is what? Positive. So 1 upon f is positive, minus 1 by u is positive. A positive number is added with a positive number. What we are going to have? We have a positive number. So basically here that 1 by v comes out to be positive. And if 1 by v comes out to be positive, v is also positive. So from here what we can see that the image distance is always positive, so it is behind the mirror. And if it is behind the mirror, obviously the image is being virtual. So this is the proof of second part. Pause the screen and note down. Now let us move to the third part. The third part is also related to convex mirror only. Okay. Let us do that. See third part. What the third part is saying? Third part says that the virtual image produced by the convex mirror is always diminished in size, that magnification should be less than 1, and is located between focus and the pole. Okay, let us see. So again for convex mirror 1 upon f is equal to 1 upon b plus 1 by u. 1 upon v is equal to 1 by f minus 1 by u. For convex mirror, what we get? F is positive, u is negative. F is positive and u is negative. So basically, from here we get 1 upon f, 1 upon v is equal to 1 by f minus 1 by u. See, 1 by u is negative, so 1 by u is also negative, but it is written with negative sign, so it becomes positive. Now what I am saying, you just listen to it very carefully. If 1 by f is being added to some positive quantity, then it becomes equal to 1 by v. Once again, u is negative, 1 by u is negative, but minus 1 by u is what? Positive. So 1 by f is added with some positive quantity and then it becomes equal to 1 by v. It simply means that 1 by v should be greater than 1 by f, isn't it? 1 by, like suppose if 10 is equal to 5 plus 3, okay, or if I want to write in this one, it should be like 5 minus minus 3. Minus 3 is negative, it is written with negative sign, it becomes positive. Sorry, it should be 8. Sorry, it should be 8. Okay. So 5 plus 3 is equal to 8, or 5 minus 3 is equal to 8. So basically here that minus 3 is negative, it is written with negative sign. So it becomes positive. Now 5 is being added to some positive quantity, then it becomes 8, equal to 8. So if you compare 8 and 5, so obviously 1 by 8 should be greater than 1 by 5. Here also 1 by v should be greater than 1 by f, or v should be less than f, if you reciprocate. So image distance is always positive, that we have proved in the last one, but it should always be less than f also. So basically image is formed between focus and the pole. Now what we have to prove? We have to prove that image is diminished also. So if image is diminished, let us see. Now magnification, which is given by minus times v upon u. Minus times v upon u. Okay. Okay. Now just see that u is negative. U is negative and v is positive. I want to write this magnitude of magnification, and the magnitude of magnification will be magnitude of v upon u. Magnitude of v upon u. Now just see that u is negative, minus 1 by u is positive, so its whole quantity becomes positive. And when it becomes positive, it simply indicates that image formed is erected. Moreover, for magnification in terms of focal length and the object distance, focal length and the image distance, we have a formula that m is equal to f minus v upon f. Okay, m is equal to f minus v upon f. Just we have proved that v is less than f, so v is less than f. So that numerator is positive. For convex mirror, f is also positive. Okay, but here this number, this f minus v should be less than f. So basically it should be less than 1. Basically it should be less than 1. Why? So because see this f minus v upon f, 5 minus 3 upon 5. It will be 2 upon 5. It is obviously less than 1. It is something like this. Okay. So magnification is less than 1. So it proves that the image should be diminished. The image should be diminished. So this is the solution of third part. Now that fourth part, I want you to solve by yourself. Okay. Fourth part is kind of your homework. Okay. Fourth part is kind of your homework. Do it on your own. And if you are not able to solve, let me know. We'll discuss it in the next part. Okay. So this is what the reflection was all about. Reflection part is over. Again the mirror will come again when we talk about combination of lenses and the mirror. So all these concepts are important. It will be again used in that part of the chapter. Let us say all for this day, all for the day. Okay. Tomorrow we'll start with refraction. Okay. Thank you all of you.